the Pythagorean theorem and special right angles. Basically, it talks about trigonometry and some other some basic things which is not that much difficult, but we're just going to start with the right triangles, and then we are just going to talk about Pythagoras theorem, and after that we are going to talk about some basic trigonometric problems, some hypotenuse, adjacent and opposite side problem, just like how does the sine, cosine, and the tan function look like. Basically, this is the sine function, this is the cosine function, and this is the tangent function. Uh, in the short form, we call this sine, and we call this cos, and we call this tan. But in some cases, you might also hear two people say that this is basically cosine function and tangent function. They say the complete word, whatever it is, and then we are just going to talk about some equilateral triangle problems. Equilateral triangle problems, basically related with the formula a equals root over 3 by 4 a squared. And then we are just going to do some stat problems, some real stat problems. So this is what we are just going to do today. Okay, so I'm going to start with the Pythagorean theorem and special right triangles. So we already know what is basically a right triangle is. A right triangle is something just like this, and what we just understand by the right triangle, the word, the phrase right triangle, that is, this angle is 90 degrees. Am I correct? Uh, and if you understand, then please do response. Okay, do respond.
Okay. Yeah.
This is basically a right triangle, and this is what we understand by a right triangle. That is, we have a 90 degree, we have an angle of 90 degree. So that will make a right triangle. So this is basically a right triangle. And we have already come to know about that a triangle has three sides. So definitely here we also have three sides, definitely. That's why we're calling that this polygon a triangle. And Pythagoras, what we have already told you, that is, there was a Greek philosopher, maybe he was from Greece, or maybe he's from basically, I really don't know the exact location, but in the ancient time, the location and the countries are not like the same, were not like the same as today. So he said that a square plus b square equals c square. What basically it means that is the the length of the opposite side, the length of the opposite side. Uh, I just want to, sorry, the length of the hypotenuse, squared of the hypotenuse is equal to the squared of the adjacent and the squared of the opposite. So Pythagoras
Okay.
says that the squared of the hypotenuse, is equal to the summation, of the squared of adjacent and the squared of this opposite. So this is basically Pythagoras is saying. Pythagoras is saying the hypotenuse squared, the length of the hypotenuse squared of the length of the hypotenuse is equal to the length of the adjacent side's length and plus the opposite side's length. This is basically what Pythagoras is saying, and I think we already know about that. What is basically the Pythagoras theorem? So this is basically a very basic thing. So we just need to solve some problem like this. So we're just gonna apply the Pythagoras theorem. We can write like x squared equals 8 squared plus 15 squared, and then we can solve this problem. So this is very easy, and the same thing. This is also the same thing. That is the hypotenuse is squared. The length of the hypotenuse squared is equal to the summation of the opposite sides length squared and the adjacent sides length squared. So, and then you just need to find the value of x. This is very simple. We already know this is the uh, this is the hypotenuse, this is the adjacent, and this is the opposite side, right?
Yeah.
Okay.
Wait, I thought the x was the hypotenuse.
Yeah, x is the hypotenuse. Yes, x is the
Okay.
hypotenuse. Yeah, and this is the adjacent side. This is the adjacent side.
Okay.
X, this is the hypotenuse, this is the adjacent, and this is the opposite. The opposite is
Okay.
the side which is basically vertical. The vertical side is the vertical side is the opposite side. The vertical side is the opposite side. Okay, the vertical side is the opposite side. This is basically a you can say this is basically kind of perspective. This is depending on how you are looking at the triangle, because what I'm saying, that is basically, for an example, if I'm draw the triangle like this, if I'm drawing the triangle like this, so how would you tell? How would you tell which one is the opposite side and which one is the adjacent side and which one is the hypotenuse? So okay, this is basically 90 degree. This the angle is 90 degree. So definitely the opposite side of the angle 90 degree of a right triangle, that is called the hypotenuse. So definitely I'm going to call this as the hypotenuse. Do you got it? Right? This is the
Yeah.
hypotenuse.
Yeah.
This is the
Yeah.
hypotenuse. And then if I'm just gonna take this angle for a particular discussion, for an example, I'm interested to talk about this angle. So if I'm just going to talk about this angle, then this is going to be our focus. This is going to be our intention. This is going to be our field of interest. So regarding this angle, regarding this angle, regarding this very angle, this green color angle, the opposite side would be this. You got it, right?
Yeah.
This is gonna be the opposite side, and then this is gonna be the adjacent side, right?
Yeah.
Okay, this is it. Okay, I'm just saying something. Okay, whatever. Okay, um, uh, same thing, same thing. This is 90 degree and this is 30 degree. You can also solve the problem by using trigonometry, and that is what we are gonna do. That is what we are gonna do today. This is example 3, and this example 3, you can also do this problem. You can also do this problem by using the trigonometry, okay? And you can use the Pythagoras theorem. You can use the Pythagoras theorem. According to the Pythagoras theorem, you can write like this, but you can also use the trigonometry, the basic trigonometry, and that is what we are going to talk about. Okay, so Pythagoras, they are just talking about some Pythagorean triple. Pythagorean triple is actually, what is a Pythagorean triple? A Pythagorean triple is okay. I'm just gonna open the page number 1. So a Pythagorean triple is the three numbers which are basically uh, causing a triple, So for just regarding this very right angle, these A, these B, and this C are 3 different lengths. And we can call this A, B, C are Pythagorean triples. You can call this Pythagorean triples. Pythagorean triples. You can call them Pythagorean triples because this A, B, and C are related with each other. By a mathematical formula, which is A squared plus B squared equals C squared. And that's why we're calling these 3 numbers together, just like a packet, we are calling them Pythagorean triple. Do you understand? Am I clear?
Yeah. Yeah.
How clear? How clear? Do you understand
I
transparently,
get
or
them.
okay, you got it. Okay, very good. Okay, you got it. So this is what is the concept of Pythagorean triples, and we have infinite number of Pythagorean triples, because you can form the infinite number of Pythagorean triples, and that's why we have infinite number of packets, packages or packets, whatever it is. You can whatever. So, and they're just talking about these Pythagorean people because uh, they're really interested to talk about some kind of multiples because not only will the above combination work as the sides for the right triangles, but multiples of them will also work, just as 5, 12, 13 could be sides of a right triangle. And this is basically what they're talking about, the Pythagorean triple. So I'm just going to focus with the next example. What is the measure of the side x in the triangle below? The simple problem. Simple problem, you can also solve it by using trigonometry, and you can also solve this problem by using the Pythagoras theorem. So whatever it is, you can also solve this problem by using trigonometry. You can also solve this problem by using Pythagoras theorem. And I suggest to use the Pythagoras theorem, and x squared equals 8 squared plus 6 squared. But I just want to focus what they are trying to do. They are maybe just trying to use some technique, some cheeky trick. That is, while you could solve for x by using the Pythagorean theorem, you can solve this more quickly by recognizing that the sides in this triangle are multiples of a 3, 4, 5 triple. The 6 is twice 3, the 8 is twice 4, so the x is twice of 5. Wow, that's an amazing shortcut. But I don't know how much effective is that. So what that saying, that is basically, as we already know that we have the concept, we have come to know about the concept of Pythagorean triple. The Pythagorean triple, for an example, uh, the one of the most basic Pythagorean triple. The example for a Pythagorean triple is number 3, number 4, and number 5. This is a very common example for Pythagorean triple. So if you just want to find, or if you just want to produce, a new
Mhm.
Pythagorean triple from these very Pythagorean triple, if you want to produce a new Pythagorean triple from these Pythagorean triple, then what can you do? Okay, then the very thing that you can do, you can just multiply with these numbers with something. For an example, you can just multiply each of them with 2, each of them with 2. For an example, if you multiply all of these, each of these numbers in this Pythagorean triple, in this bracket, then you get 6, you get 8, and you get 10. So this is a new Pythagorean triple. A new Pythagorean triple. Okay, so
Yeah.
this is
Yeah.
basically what they're talking about. So maybe you just need to remember some Pythagorean triples, then you can just easily solve. But basically, I think this is nothing but memorizing something. So the best thing to do is, um, I don't know whether calculator is approved here or not, but if calculator is approved, usage of calculator is approved, then you should definitely use the calculator. Or if it's not uh, legal, then memorize this cheeky trick, 3, 4, 5, deriving a new Pythagorean triple from a very basic Pythagorean triple. I think this is very useful if the calculator is not provided. You got me.
Mhm.
Do you have any
Yeah.
question?
No, no, not so far.
Okay, all right. So we have some practice problems. Let's look. What are the practice problems? If two legs in a right triangle are 9 and 40, what is the length of the hypotenuse? Very, very basic problem. We can do it because 9 and 40 are two sides, and this is not definitely the hypotenuse. So the hypotenuse would be root over 9 squared plus 40 squared, right? Do you got it?
Wait. Oh, yeah. Yeah.
Yeah, that's a very basic problem. For an example, they're just for a right triangle, For a right triangle, we're already given this side 9 and this side 4. Maybe 9 and 4. 9 and 40. Sorry, 9 and 40. 9 and
Yeah.
40. Yes. So we're just asking what is the side of this side. This side. Tick mark side, right?
Yeah.
You can
Yeah.
just do the
9 square. Yeah.
and
40
then
square.
do it. Right?
Yeah.
Yeah, that's easy. I think that's easy. Okay, so problem number 2. If the hypotenuse in a right triangle is 61 and one of the legs is 60, what is the leg length of the other leg? The same problem, same problem, just you just need to use the Pythagorean theorem, and then you just need to put the value of the hypotenuse, and then you just need to put the value of another side, and you just need to consider maybe you are just finding the opposite side or the adjacent side. Whatever it is, the number would be the same. The number would be the same. It doesn't matter whether you are just thinking a particular side for a right triangle as an opposite side or an adjacent side. If you're just taking this as a opposite side, and if you're just taking it as a adjacent side, it doesn't really matter. It doesn't really matter. The number packet, the Pythagorean triple are always the same for a given triangle, for a given right triangle. So it doesn't really matter whatever you're just thinking about. The only thing that is you just need to do that is don't mess up with the hypotenuse. Don't mess up with the hypotenuse. Okay?
Okay.
Do you understand what I'm talking about basically?
Yes.
I'm just
Yes.
talking about this. That is, you can just consider two scenarios. This is 61 and this is 60 and this is what. And for another triangle,
Yeah.
you can also just consider like this is 61, this is 60, and this is what. This is what. This is what. Okay?
Mhm.
So it doesn't really matter if you are just calculating this side or this side. They all are the same. They all are the same basically. Maybe just you're just looking at this right triangle like this, or maybe you're just looking the right triangle like this, like this. Sorry, give me a moment. Like this. Whatever it is, the triangle is the same. Do you
Okay.
understand?
Yes.
Okay, I think you will understand more. Just do some practice
Yes.
problems. Okay, two legs in a right triangle are equal to y. What is the value of the hypotenuse in terms of y? Two legs in a right triangle are equal to y. What is the value of the hypotenuse in terms of y? The hypotenuse is square is equal to the sides of one side square and the another side square. So, okay, so h squared is equals to 2y squared. So then h is equals to root over 2y. Do you got it?
Yeah.
Yeah, that's very simple. If the
Yeah.
hypotenuse in a right triangle is equal to 50 and the smaller leg is equal to 14, what is the length of the third side? It's very simple problem. Very simple problem. It's all are the same. If the sides in a right triangle are 4 root over 3 and 8, what is the measure of the smallest angle in the triangle? Okay, okay. So I'm really interested. I'm really interested about how they're solving this problem. Are they using the Are they really using the trigonometry, or are they using some different type of approach? I'm really interested because you can solve this problem by using trigonometry very easily. You can solve this problem, but what are they really trying to do? That is, I'm just gonna focus in the solution. Okay, since the sides have the ratios, x root over 3 and 2x with x equals 4, the triangle will have angles of 30 degrees, 60 degrees, and 90 degrees. The smallest angle will therefore have a measure of 30 degrees. I really don't understand what is the point of solving this problem just like memorizing technique. This is basically a memorizing technique. So I'm just gonna look at the real SAT problems to look like. How does the real SAT problems look like? They're just giving 12 minutes. They're just giving you 12 minutes, and they're just asking you to solve some problems. That is basically, they're not asking you to use a particular method. You can solve any problem by using any kind of method. It doesn't really matter. It doesn't really matter which approach, which method you're just using to solve your problem, which method you're just using to approach a SAT MCQ. This is a multiple choice question. So maybe some of the problems, a lot of problems regarding geometry and trigonometry become simpler if you are just using some trigonometric approach. So definitely you should do that. Definitely you should use the trigonometry, and please don't memorize unnecessary things that you really need to think about. Please don't memorize such things which are not necessary to memorize, because you can solve those kind of problems very easily if you're just gonna do some other approach other than it is suggested by the solution, by the solvers. Basically, they're just provided here. Okay, you got it, right?
Yeah.
Okay. If you have any question, then you can ask me. Do you have any question till now?
No.
Okay, all right. So now we're just gonna enter in. We are really interested to talk about trigonometry. Basically, just some basic trigonometry. So what actually trigonometry is? What actually trigonometry is? Trigonometry is basically finding the values of three angles. That is the source of the word trigonometry came from. That is the source of the word trigonometry came from. Finding the values of three angles, finding the values of three angles, Okay, so this is basically trigonometry, because every time we're just gonna talk about a triangle, whatever it is. We're just gonna talk about a triangle. We're just gonna talk about a right triangle, and a lot of times we're just gonna model some problem with the right triangle analogy. Okay, and the analogy is a very important word, because the analogy, it gives you some intuitive way to relate with each other. For an example, uh, consider a situation. This is basically a situation A, and a situation, this is B. This is situation B, and for the situation A, we have a parameter. That is basically called A, and for the situation B, capital B, we have a parameter called small b. So if I repeat, if the situation capital A and capital B are related with each other, then we can also tell this A and this B, small b, are related with each other. This is basically called the concept of analogy. Okay, and a lot of times you will really solve so many problems by using analogy. And why I'm talking about this, because we are just gonna model so many real problems by using the right triangle analogy, by using the trigonometric analogy. So that's why I'm just talking about what is basically the analogy is, and why do we need to understand the trigonometric analogy, because the trigonometric analogy will take the approach to model a scenario by using a right triangle, and then you just gonna apply some basic trigonometric rules, some basic trigonometric rules. Okay, do you understand what I'm talking about?
Yeah.
Okay, so trigonometry is finding the values of three angles. That's quite simple. This is the definition of trigonometry. Sometimes we call that trig, dot trig. Okay, so before we're starting the trigonometry, I'm just gonna review what I've just talked about a few minutes earlier. That is basically hypotenuse, and then the opposite and the adjacent. The hypotenuse, the hypotenuse is the hypotenuse is the side which is which is located opposite of these 90-degree angle of a right triangle. So for this red shaded side is called the hypotenuse, and the okay, give me a moment. Okay, the opposite side is the angle. For an example, if you're just talking about this angle, if you're just gonna talking about this purple angle, this purple color angle, just look at my point, this purple color angle, then the opposite side for this right triangle is this side, and the adjacent side will be this side. And in some other scenario, if you're just taking this angle for your relevant or interested angle, then this is gonna be the opposite side, and this is gonna be the adjacent side. So the adjacent side and the opposite side is basically a respective thing that is quite dependent on how you're taking the angles and how you are discussing, how you are focusing on which angle and how to measure that angle. Do you understand what I'm talking about?
Yeah.
So it means that this also can be opposite side, and this also can be the adjacent side. It is depending, because here we are just taking this angle. This is our field of interest. This is our field of interest. This is our focus. So regarding this angle, this is going to be the opposite side. Regarding this angle, this is going to be the opposite side, and that's why we're calling them. This is calling this side as the opposite side. But if I'm just going to take this angle as a relevant angle, our interested angle, then this is going to be the opposite side. This is going to be the opposite side, and this is going to be the adjacent side. Okay, you got it, right?
Yeah.
It's going to be the opposite side, and this is going to be the adjacent side. But the hypotenuse will always remain the same, because the angle 90 degrees is not changing, and that's why the hypotenuse will always remain the same. And this is what basically they're talking about. So okay, so we are gonna talk about sine, cosine, and tangent. Sine, cosine, and tangent. So this is where the trigonometry, this is where the real trigonometry is gonna enter. So how the real trigonometry look like? The real trigonometry look like some ratio. The real trigonometry look like some ratio. How the real trigonometries look like the ratio? Okay, let me clean some image, some things. Okay, okay, all right, all right. Mm. Uh, Sine function, the cosine function, and the tangent function. The sine function, the sine function. Please remember that trigonometry basically talks about ratios, ratios of the length, ratios of the length of sides for a right triangle. This is basically what uh, basic definition for the working of trigonometry can be ratios of the length of sides for a right triangle. So, okay, so what is a sine function? A sine function is basically a ratio for two different sides for a right triangle. A sine function is basically a ratio for two different sides of a right triangle, depending on the angle that we are interested to measure and the definition of our sides that is relevant to the angle that we are interested. So what does that mean? What does that mean? That it means that consider this thing. Okay. Okay, wait. Consider this thing. This is basically our angle of interest. This is basically our focus. This is basically what we are interested to measure. The angle we really want to measure. This is the angle we want to measure. This is basically the angle we are really interested to talk about. This is our focus. And for this very angle x, we want to perform some basic trigonometric things. So the basic trigonometric things, some basic trigonometric operations will occur or will give birth of some different type of ratios. What does that mean? It means that if you're just taking this angle x for an input, if you're just taking angle x as an input, and then if you're just gonna put it in as an input of a trig function, you just need to calculate the value of this trig function of x with a ratio. A trig function or a trigonometric function. A trig function is basically the abbreviation for trigonometric function. We call trig function to save some time, basically. So trig function is just a ratio for a right triangle. So what does that mean? It means that a trig function, a sine function looks like this. Looks like the ratio of opposite side and the hypotenuse side. For a given right triangle, for an example, this is our given right triangle, and for this very right triangle, if we want to find the sine of theta, this is our theta, and we just want to find the sine theta. The sine is a function, a trigonometric function, and theta is the angle. As we already said that x is the angle here. This is x, and x is the angle here. So theta is also an angle. So the angle is the input for a trig function. The angle is the input. The angle is the input for a trig function, and the trig function for a right triangle is a ratio. Do you understand what I'm talking about?
Yeah.
So it means that for a very basic right triangle, the sine theta would look like a ratio, and that is the opposite side and the hypotenuse side. The same thing also goes for the cosine function, the tangent function, and the ratio just changes because there are three sides. There are three sides for a right triangle, and we can do six combination. We can do six combination because for each combination, we are just taking two sides for each combination of ratio, because this is the ratio. A ratio, for an example, opposite side divided by the hypotenuse. Consider this is the ratio. We have also five different ratios. And we have in total six trigonometric functions. Sine, cosine, tangent, cotangent, secant, and cosecant. So these 6 trigonometric functions in total, and to combine two different sides, this is one side and this is another side, and to combine two different sides, we can make for three different sides. We just want to make a ratio with two different sides. We can make in total 6 combinations. That is what I'm basically talking about, because we have 3 sides, but for each combination we are allowed to take 2 sides. This is basically a problem of permutation and combination. So why the 6 different trigonometric function is coming from? Why there is happening 6 different ratios? This is what I'm giving you the explanation, because we can take opposite side divided by the hypotenuse side. We can also take the hypotenuse side divided by the opposite side. Okay? Do you understand?
Yes.
We can take the adjacent side. We can take the adjacent side divided by the hypotenuse side, and we can also take the hypotenuse side. Divided by the adjacent side. We can also take the. Do you understand?
Yes.
Is there any issues?
No, it's fine.
We can also take the hypotenuse side, and we can also take the divided by the adjacent side, and that is gonna be the sec, because the sine function is the opposite of the cosec function. The sine function is the opposite of the cosec function, and the cosine function is the opposite of the sec function, and the tangent function is the opposite of the cotangent function. So maybe they are discussing those topics here, and if they are not discussing that, it's okay. But I'm just telling you for your kind information. I'm just telling you that there are 6 different trigonometric functions. We can create 6 different trigonometric functions. We have 3 sides. For a given right triangle. Definitely a triangle must consist of 3 different sides, and for 2 different sides, basically that is a combination. Ratio must consist of a denominator and the numerator. A ratio must consist of a numerator and the denominator. So definitely we're allowed only take 2 sides to make a combination, and to consist different ratios by taking 2 different sides. For a 3-sided polygon, we can make 6 different combinations, and that is why we have 6 different trigonometric functions. The trigonometric functions are basically, we have so many different types of trigonometric functions, but for the simplification of this lecture, because if I talk a little bit deep, then the syllabus will go beyond the scope of our SAT syllabus. So for the simplification, I'm just telling you these are the natural trigonometric functions. The natural trigonometric functions are 6 types: the sine function, the cosine function, the tangent function, the secant function, the cosecant function, and the cotangent function. Do you got it or not?
Yeah.
Okay, all right. And definitely the ratio for each particular identical trigonometric function, the ratio is very identical. If you just make this adjacent into opposite, then the ratio will change. The ratio will change. You cannot just write the opposite side divided by the hypotenuse side is cosine function. No, you cannot write that. You cannot write that. You cannot write that the opposite side divided by the hypotenuse side is equals to cosine function. No, that's not correct. That's wrong. That's wrong. No, no, no way. Because each of them is very identical. Each of them is very identical. The opposite side divided by the hypotenuse side has a particular name. The adjacent side divided by the hypotenuse side has a very particular name. The opposite side and the adjacent side has a very particular name. And most importantly, we are interested to talk about the angle of interest. The angle of interest. Here it is our angle of interest. If this is the angle of interest, then the definition will change. Why? The definition will not change for the trigonometric function, rather than the functions, input, the ratio, the sides will change. The sides will change. And then for these angle of interest, this is going to be the opposite side. This is going to be the opposite side, and this is going to be the adjacent side. Do you got it? What I'm talking about?
Yeah.
Okay, all right. So this is basically what trigonometry talks about. Very simple. Let's do an example. Okay. All right. What is the tangent for angle x? Angle x in the right triangle below. Okay. You can take any kind of trigonometric function that you're really interested. You can take any kind of trigonometric function, but for the simplicity, basically, I'm just thinking about tangent function. Because I love tangent function. And that's why I'm talking of the tangent function. So, okay. For this interested angle, our focus is this angle. This green shaded angle, this angle. We can write the tangent as this side divided by this side. You got it or not? Do you understand what I'm talking about? Because for the tangent function of x, this is basically our field of interest. This is basically our angle of interest. So for this angle, the opposite side is 4, and the adjacent side is equals 3. So the tan function, the tan of x becomes 4 divided by 3. So x is equals to tan inverse. You can also write like this, or you can write like in another way. Maybe this is not allowed for your syllabus, writing like the inverse function, maybe, whatever it is. I will talk about that later. But you can just write like x equals tan inverse 4 by 3, x equals tan inverse 4 by 3, x equals tan inverse 4 by 3. So this is basically the solution. Do you understand or not? You can ask me anything, any question.
Why are you dividing that again?
Sorry?
Why are you dividing that? The 4/3?
Yeah, because I'm dividing them because this is what I'm talking about. This is basically, I'm talking about the ratio. Because we are interested about the ratio. Because without any ratio, there is no existence of any kind of trigonometric function.
Oh, okay. No, I get it.
If there is no ratio, no trig function.
Okay.
No ratio, no trig function. And that's why I'm dividing. Because the division is the ratio. The division is the ratio and the ratio is the division. The division is the ratio and the ratio is the division. So they're they're the same thing. Dividing something by something, dividing something A divided by B, dividing A divided by B is a ratio. And that's why you are dividing. And a trigonometric function is basically a ratio. A trigonometric function is a ratio. A trigonometric function is ratio. Ratios of the length of the sides for a right triangle. Ratios of the length of the sides for a right triangle.
Okay.
This is trigonometric function. For a given trigonometric function, the ratio is identical. The opposite side divided by the hypotenuse side. If we divide the opposite side divided by the hypotenuse side, then we get the sine function. And you cannot write, for an example, for a cosine function, you cannot write the opposite side divided by the hypotenuse side is equals to cosine function. No, you cannot write that. You cannot write that. You cannot write that. No, you cannot write that. Do you understand what I'm talking about?
Yeah.
Because the definition for the cosine function is constant. The definition for the cosine function is constant. What is the definition for the cosine function? What is the definition of the cosine function? What is the definition of the cosine function? The definition of the cosine function is the adjacent divided by the hypotenuse. This is the exact, correct, and constant definition. It will not change. It will not change. This is the exact correct definition for the cosine function. So you cannot write the cosine function is equals to the opposite side of the and divided by the hypotenuse side. No, this is not the correct cosine function. It has a definite name. It has a definite name. It has a definite name, and this is the definition for the sine function. This is the sine function. So you cannot write the sine function is equals to the cosine function because each of them has a very, very, very identical combination of two different sides for a given trigonometric function. There are 6 different trigonometric functions because for a right triangle, we have 3 sides. And for 3-sided polygon, taking 2 sides and making them ratio, you can make it 6 different ways. And that's why we have 6 different ratios. And that's why you have 6 different names. And that's why you have 6 different trigonometric functions. Do you understand or not?
Yeah.
All right.
Yeah.
All right. So that is why we are dividing it, because we are really interested. We are really interested to take about the ratio. For an example, let me tell you something. For an example, sorry for the bad handwriting. I'm sorry for my bad handwriting. If this is angle theta, this is angle theta, and we're asked to find the value of theta, then how do we do? The way that we do that is basically we just want to apply a trigonometric function related with theta. Apply a trigonometric function, apply a trig function related with theta. So what is a trigonometric function related with theta? There are 6 different trigonometric functions related with theta. What is that? Sine function, sine theta, cosine function, cosine function, cos theta, tangent function, tan theta. We have cosec function, we have cosecant function, cosec theta. We have secant function, sec theta, and we have cotangent function, that is cot theta. We can take 6 different functions for this very angle theta, But we don't need to make such a complicated situation. We can do it very simple. We can do it very simply just by taking, okay, Think about tangent function. Think about tangent function. So the tan theta, so the tangent function for these angle theta, the tangent function for this angle theta becomes the opposite side divided by the adjacent side, because you just need to memorize. You really need to memorize what is the definition of this sine function. The definition of the sine function, the definition of the sine function is, the definition of the sine function is, the definition of the sine function is opposite side divided by the hypotenuse side. This is constant. This is constant. There's no change. This is constant. The definition is constant. It will not change. So you really need to remember. You really need to memorize this. You really need to memorize this. You really need to memorize this because this is very useful. You will always need it. You will always need it. There's no change. Okay? There's no change.
Okay, I have a question.
Okay, sure.
Yeah, so the three sine, cosine, and tangent, okay, fine, I get that. But what's the function for the other three? Like, what would you divide?
Are you just asking about this triangle?
No, the cotangent, cosecant.
Okay, the cotangent. Okay, the cotangent has a definition. The cotangent has a definition that is the definition of cotangent. What? How can I get a phrase this? Okay, I can write here. The definition of the cotangent, cot theta is equals to can write like the adjacent side divided by the opposite side.
So you just flip them?
Sorry?
Do you just flip the original? Like the tangent is opposite over adjacent, so do you flip that so it's adjacent over opposite?
Yeah, that is a way of thinking, basically. That is not only a way of thinking, and that is what actually it is. That is basically that because the cotangent function and the tangent function are opposite. Reciprocal. You cannot tell them this is opposite. You just need to tell them reciprocal. This is reciprocal. I'm sorry, reciprocal. So tan theta is equals to 1 by cot theta. So if you remember the definition of tan theta, then you can definitely find the definition of cot theta. Is that simple?
Oh, yeah.
Do you understand?
Wait, what did you mean? 1 over cot?
Okay, 1 over cot. Okay, 1 over cot. What is the meaning of 1 over cot? This is basically a ratio. This is basically for an example, if you want to mean, for an example, two things are reciprocal. For an example, let me make you understand. Solid and liquid. Solid and liquid are two different things, and they are opposite to each other. Just consider a situation, a real life situation. Solid is a type of matter and liquid is a type of matter. So according to the language of mathematics, you can write solid is equals to 1 divided by liquid. This is the language of mathematics, and this is called reciprocal rule. Reciprocal rule. Do you understand what I'm talking about? This is a mathematical definition, a mathematical concept. So the tangent function is the opposite of the cotangent function. So that's why I'm writing like 1 over
Oh,
cot over 1 over the cot. 1 over
oh,
cot. Do you got it?
yeah.
Because the solid is the opposite of liquid. So
Okay.
you can write according to the language of mathematics, the reciprocal rule. You can write according to the rule of reciprocality. You can write solid equals 1 by liquid. You can also write. 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 You can also write liquid. You can also write liquid is equals to 1 by solid. You can also write liquid equals 1 by solid. Okay, because these two things are 100%, 100%. And if you just apply the basic equation rules, you can apply the basic equation rules, then you can basically understand that these two these two lines or these two arguments are basically nothing but the alternative form of each other. Just cross multiply it, liquid cross solid was 1, right?
Okay.
Divided by now according to the rules of equation, divide each term with liquid solid liquid, okay, equals 1 by liquid. Okay, now this liquid and liquid become cancelled, and then after vanishing them, solid becomes 1 by liquid. You got it or not?
Yeah.
Okay, let me write you for the tangent function. I told you that the tangent function tan theta is equals to 1 by cot theta. Okay, so this is basically the rule of reciprocality. The rule of reciprocality. So you can write according to the law of equations, you can write tan theta multiplied by the cot theta is equals to 1. And now if you divide cot theta, if you divide tan theta in both sides, then it looks like tan theta cross cot theta divided by tan theta is equals to 1 divided by tan theta. This tan theta is tan theta cancel, and then cot theta remains single here. Cot theta equals 1 by tan theta. Okay, but the first line that we wrote here, this is tan theta equals 1 by cot theta. So you can definitely pull this answer from this answer. Basically, this is not answer. This is basically some argument. This argument from this argument. From this argument, you can also write this argument from this argument. Do you understand or not
Yeah.
what I'm talking about?
Yeah.
It's quite simple. Some basic mathematics. Some basic mathematics here. Some pretty simple basic mathematics here. Anyway. Okay, so this is how we do it. This is how we do trigonometric things. This is how we really do trigonometric things. And what is sin x? What is cos x? They're really asking you, for an example, they're asking you to tell about the basic definition for this very, very, very right angle. Okay, this very, very, very right angle. So what does that mean? What does that mean? It means that the sin x is our field of interest. This is basically our field of interest. This is basically our angle of focus. So we are really interested to think everything right now at this very moment in terms of x. Everything in terms of x. Don't mess up with this angle y right now. Don't mess up with this angle right now. Just think about from the perspective of x primitively, because we have also x and we have also y. Basically, we have three different angles. But for the angle x, the definition of sine, and for the angle y, the definition of y is not the same. What does that mean, and how we can write those things in mathematically? We can write the sine of x is not equals to the sine of y. The sine of y, we cannot write this. We cannot write this. The definition for the sine function, sine of x, and the definition of the sine of y here are not the same. Are not the same. But the sine function, but the definition of the sine function intrinsically for any kind of trigonometric application, the definition of a sine function is always opposite divided by the hypotenuse. So for these these right triangle, sine x would be the opposite side divided by the hypotenuse side. So what is the opposite side? For these right triangle, for these angle x, for these angle x, for these angle x,
5.
the opposite side is the 5. Yes, exactly, the 5 divided by the hypotenuse side. The hypotenuse is 13. 13. This is the sine of x. But for the sine of y,
12 over 13.
the opposite side would be 12. The opposite side would be 12 divided by the hypotenuse side. That is 13. So it's very simple. For a given right triangle, this given right triangle, the sine x is not equal to the sine of y. The sine of x is not equals to the sine of y. But the definition of the sine function, it is always the same. Opposite divided by the hypotenuse. Opposite divided by the hypotenuse. Opposite divided by the hypotenuse. This is always same for any kind of trigonometric application for this very particular trigonometric function called the sine function. Do you understand?
Yeah.
I think you should understand. There's
Yeah.
no way of not understand, because I'm really trying to make you understand. Okay. So sine of x, we can find sine of x. Definitely we can find sine of x. We can find cos of y. We can find tan of y. Okay, so do it. At least do it. Okay, let's try it. So how does the sine of x look like? The sine of x will look like 5 by 13. The sine of x will look like the 5 by 13. The cos of y will look like, what is the definition of cos of? What is the definition of cos? What is the definition of cos? The definition of cos is the adjacent divided by the hypotenuse. You remember that. You need to remember this. You need to remember the definition. You need to remember this definition for the sine function, this cosine function, this tangent function. Otherwise, you cannot apply. You cannot apply this because you need to memorize this.
Okay.
So
I know.
the definition of cos function, the definition for the cos function, cos theta, consider theta is adjacent okay. Now So what is cos y? For the cos y, the adjacent side is 5. The adjacent side is 5 cos y. Adjacent side equals 5. And the hypotenuse, that is 13. Do you understand?
Yeah.
Yeah. So the same also happens for the tan function. The same, if the same also happened, it means that you also need to apply the definition. You just need to apply the definition. You just need to remember the definition, then plug the values, and then find the answer. That is very simple. That is very simple. It is just depending on which angle you're interested, and from the interested angle, which one is the adjacent side, which one is the opposite side, and which one is the hypotenuse. You just need to look at the angle. You just need to look at the angle, and then you just need to look from the view of the angle. Which one is the opposite side? The opposite side of the angle is the opposite side. The adjacent side of the angle is the adjacent side, and the side that is basically opposite of the right angle, that is the hypotenuse. This is very, very, very simple. You just need to do some practice, and then you will automatically understand. Okay.
Yes.
Do you understand what I'm talking about?
Yes.
Do you understand? Sorry?
Can you do number 4?
Sorry?
Can you do number 4?
Okay, yeah, definitely. Yes. Yeah, I was going to do that. I was going to do that. In a 45, 45, 90 triangle, which values will be identical? Which values will be identical? In a 45, 45, 90 triangle, which values will be identical? It is basically meaning that you just need to consider such a triangle, such a right triangle, for which uh, the values are like 45, 45, and 90. What does that mean? It means that this is a right triangle, this is 45 degree, this is 45 degree, and this is also 45 degree, and this is 90 degree. This is 45, 45, 90 degree triangle. Which values will be identical? Which values will be identical? It means that you just need to find the cos 45, the sin 45, and the tan 45. Apply for the cos 45, apply for the sin 45, and apply for the tan 45. Apply for the, just find the answer for these cos 45. And then find the value of the these angles sine function, and then find the value of this tan function. For consider this angle as theta, and then find cos theta, and then find cos theta, and then also find the cos theta for this side, this angle.
Mm-hmm.
Then now compare.
Okay.
Then now compare if these two ratios are same. Is this two ratio same or not? Same or not? Same or not? This is what they are meaning, trying to tell you identical now.
Okay.
This is 45. This is 45. And this is 90. Now apply sine 45, and then sine 45, and find the ratio, the value of this sine 45, and find the value of this sine 45. And then compare if these sine 45 and if these sine 45 are identical or not, equal or not, same or not. Then you just need to compare. Basically, they are not just giving a very good explanation, an extended explanation, but I'm just telling you the exact thing, basically. I'm just telling you the true thing, because they're telling you 45-90 triangle, the sides have a ratio is uh, is 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 root 2, 1 and 2 are equal, since cos 45 and sin 45 both has 1 by root 2. Okay, so let me give you some expansion. In a 45-45-90 triangle, in a 45, this problem, in a 45-45-90 triangle, which values will be identical? So if you want to solve this problem, then you just need to do some techniques. You just need to apply some techniques. How that technique will look. Okay, so consider this is our triangle. This is 45 degree. This is also 45 degree, and this is 90 degree. Okay, so now write this side as A, and this side as B, and this side as C. So for these angle, find the value of cosine function, cos 45 degree, and then for this angle, find the value of cos 45 degree. And again, find the value of sine 45 degree for this angle, and then sine 45 degree for this angle. Okay, and we need to find the value of tan. Okay, 10 45 degree, and then 10 45. This is what you need to do, and then you need to compare, because each time the value that will appear for the cosine function, for example the cosine 45 degree, just consider this angle. The definition of the cosine function is adjacent side adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. So that will appear like for these highlighted angle, for this angle, the adjacent side would be B divided by hypotenuse equals to A. And for these 45 degree, cos 45, for this cos 45, the definition of cosine function will remain same. For this cos 45, the adjacent would be C. Do you understand what I'm doing actually, or you are just watching?
I don't really get it. I'm just
You,
watching.
you are not getting it, right?
No.
Okay, you are not getting it. So what is the problem? What you are not understanding? What things are causing you problem?
So, like, how are you, like, what are you doing? Like, why did you write cosine 45, sine 45, tan 45?
Okay, why I'm doing this? Because this is our problem. In a 45 90 degree triangle, 45 90 triangle, which values will be identical? We're just trying to solve this problem. We're
Oh,
just
okay.
trying to solve. Do you understand?
Yeah, yeah.
So what can you do basically? Tell me, what can you do to
Draw
solve
a,
this problem 4? What can you do?
um,
I'm
draw a
just
triangle.
solving this problem. I just told you what to do. At least if you don't understand, then you just need to tell me that you're not understanding. I just told you how can I solve this problem? I have just the very first thing that I have done, that is I have just drawn a right triangle. This
Yeah,
is a right triangle. This is a 45 degree, this is 45 degree, and this is 90 degree. I've just
yeah,
drawn a triangle. And then values will be identical means that the cos 45 has two different values. Because this is 45 degree and this is also 45 degree.
yeah.
So we can apply the cosine function for this angle, and we can also apply the cosine function for this angle. Do you understand?
Yeah. But
No,
isn't it gonna be the same answer?
sorry?
Is it gonna be the same answer though? Because it's both 45.
That is what we are gonna test. That is what we
Okay.
are gonna asking. That is what we are need to find it. That is what we just need to find out because we don't know because we really don't know whether the values are identical or not. If they're identical, that's okay, fine. And if they're not identical, that's also okay. But we just need to find out which values are identical. And to do that,
Mm.
to do that, we are calculating. And for the calculation, for the purpose of calculation, we are considering the length. For an example, this is A, this is B, and this is C. We are considering the length of the sides of the triangle. And this is B, this is A, and this is C. That is what I have written here. Do you understand?
Yeah.
This cos 45 is C by A, and this cos 45 equals B by A. So they're not identical.
Mhm.
They are not identical, not identical, not identical, not identical. Do you got it?
Yeah.
Now for the sine 45, what will happen? Tell me. For the sine 45 and the sine 45, we have two different sine 45. Tell me, what is the sine 45 for this angle?
For
Okay.
that one,
Let me write it. Let me write in a clear place. Okay.
okay.
Okay. This is 45 degree, and this is okay. This is 45 degree. What is the value of sine 45 degree? And what is the value of sine 45 degree? You just need to tell me. This is A, this is B, and this is C. Now you tell me the answer. I'm not going to tell anything.
Okay. For the blue one,
For
it
the
would
blue
be
one, for the blue one, for the blue one, for the blue one, for the blue sine 45 degree, for the blue sine 45 degrees. Tell me the answer. For the
C.
blue sine 45 degree.
That would be A over C or C over A,
You're
right?
telling that for the blue sine 45 degree, for the blue sine 45 degree, the answer
Yeah.
would be, you tell me the answer.
C over A,
C over A. Okay. So now tell me for the red sine 45 degree,
B over A.
B over A. Is it correct or not?
No.
Is it correct or not?
What do you mean? Like the answer?
Yeah. Just tell me, are you confident or not? I'm
Yeah.
just asking you, are you confident?
Yeah.
Are you confident about your answer or you are not
Yeah.
confident about your answer?
And
Okay, you are correct. You are correct. For the red one, that is also correct, and for the blue one, that is also correct. For
okay.
the red one, this is basically B and this is basically A. It's correct. B by A and this is C by A. So is these two sine 45 identical or not? What does that mean? Are they same? This sine 45 degree and this sine 45 degree are they same? This is
No.
C by A, this is B by A. Are they identical?
No.
No, because for a sine 45 degree we have C by A and for a sine 45 degree we have B by A. Are these two are identical?
No.
No, these two are not identical. But there's a thing basically. There's a thing basically. The thing is, this B and this C are equal. Why? You tell me the answer. Why this B and C are equal?
They're both the 45 degrees.
Yes, exactly. 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 Because the same amount of angle, the same amount of angle, the same amount of angle has the same amount of angle, the same amount of angle has the opposite side of equal length, has the opposite side of equal length. So it means that this B is equals to C. So what is C by A? That is also B by A. Doesn't really have any change, doesn't really have any kind of change of values. So they're identical. So they are basically identical. It means that this sine 45 and this sine 45 are same, so they are identical. For the cosine function, this cosine function, this is also identical because these are 45 degree. So if it is not 45 degree for the both angle, then it is not identical. But as they both the angle, this angle and this angle are 45 degree, so they have the equal length of the sides, this B side and the C side. So that's why you can call them identical. Do you understand or not?
Yeah.
Do you understand or not?
Yeah.
It's a very tricky problem. It was a very, very, very tricky problem. I think it's very, very, very good problem for someone who doesn't really have any kind of knowledge about trigonometry. Area of an equilateral triangle. What is basically an area of an equilateral triangle? Let me write it down. Let me draw here. An equilateral triangle is basically a triangle which has the same amount of length for each side. A triangle is basically a three-sided polygon. So our equilateral triangle has three same length sides, same length side. This is A, and this is also A. We have A, and we have A. So the area of this triangle, that would be A equals root over 3 divided by 4 A square. Simple. This is the equation. This is the law of the area of the equilateral triangle. Okay? You just need to take a value. You just need to take a value for any side, and then you just need to plug in the value. This will give you the answer. Sine and cosine of complementary angles. So sine and cosine of complementary angle, this basically means that you can just transfer the sine function to the cosine function, and you can also transfer the cosine function in the sine function. These two are alternating. These two are interchangeable. These two are interchangeable. These two are interchangeable. In what terms? The equation or the law is sine of x is equals to cosine of 90 degree minus x degrees. So this is basically the rule. This is basically the rule telling you that the sine function can also be transferred to cosine function, and the cosine function can also be transferred to the sine function. And this is basically the relationship. This is the relationship. So what does that mean? For an example, the sine of 30 degree is equals to the cosine of 90 degree minus 30 degree, which is the cosine of 60 degree. So the value of sine 30 degree is the same of cosine of 60 degree. This is what does complementary angles of sine and cosine. Do you understand?
Yeah.
It's very simple. It's very simple. It's very simple. And if the sine of 30 degree is 0.5, what is the cosine of 60 degree? If the sine of 30 degree is 0.5, what is the cosine of 60 degree? Okay. So the sine of 30 degree, is equals to the cosine of 60 degree. The sine of 30 degree is equals to cosine of 90 degree minus 30 degree is equals to cos 60 degree. So we know the value of sine 30 degree, that is 0.5. So we can also tell the value of sine 60 degree is 0.5. Do you understand? Am I correct?
How do you wait?
I'm
You
telling
did
you the
not.
answer. Again. Giving you the explanation again. Okay. So we have been told that the sine of 30 degree, the sine of 30 degree the sine of 30 degree is 0.5.
Yeah.
We are given, okay? This value is basically given. This value is 0.5 is given here. This 0.5 value is given here. And we just need to find the value of cosine of 60. What is the value of cosine of 60? Cos 60 degree. What is the value? What is the value of cos 60 degree? We're just being a little bit of tricky. We're just becoming a little bit of trickstering technique. So we can write that sine 30 degree is equals to cosine of 90 degree minus 30 degree. How can I write? Because we have come to know about this equation, this law. This is basically a law. The law of sine and cosine of complementary angles. This is basically a law. This is a law. This is a law. And from this law, we can write that sine 30 degree is equals to cosine of 90 degree minus 30 degree. Sine of x is equals to cosine of 90 degree minus x. Do you understand at least at this point?
Yeah, I do.
And just 90 degree minus 30 degree equals to 60 degree, cosine of 60 degree. So it means that sine of 30 degree is equals to cosine of 60 degree. Sine of 30 degree is equals to cosine of 60 degree. Sine of 30 degree is equals to cosine of 60 degree. And we are given that the value of sine of 30 degree is equals to 0.5. So the value of cosine of 60 degree is also gonna be 0.5. Am I correct?
Can you explain how?
Okay, sine of 30 degree is already given. The value of sine of 30 degree is 0.5 is already given. Okay. The value of sine of 30 degree is 0.5 is already given. Basically, this is 0.5. We have given, we have been told. And how do you find the value of cosine of 60 degree? This is because we have already told you that the value of sine 30 degree is equals to cosine of 60 degree because we have mathematically proved here. We have mathematically proved here. This green shaded highlighting moment here, we are proving here that sine 30 degree is equals to cos 60 degree. As we already know the value of sine 30 degree given here in this question, as the sine 30 degree equals to cos 60 degree, and we are given the sine 30 degree value, then we can write that cos 60 degree equals to 0.5. It's simple. Just go through the problem. I think you just need to go through, and I think you just need to just answer. You just need to do some practice, okay? And you really need to. If you do some practice, then you will automatically understand what I'm basically talking about, because this is a very simple thing, and I think it's not just practice. You just need to have a little bit of concentration things. You just need to try to grow up the concentration anyway. So we just need to do some mathematical problems, set math problems, practice real. So additional topics in math, right triangles and trigonometry. So this is going to be 12 minutes, real life set problems, 12 minutes. This is going to be their homework, okay? This is going to be your homework, and you just need to do all of the problems